You ever look at your smart light bulb or your thermostat and just wonder, how does that actually work? Is it magic? Well, no, not really. It all starts with something tiny, a single super powerful chip. And today, we're going to pull back the curtain and demystify the whole process, all the way from a little piece of silicon to a smart device you'd have in your home. All right, let's get into it.
So here's our game plan. We're going to follow the exact path an engineer would take. First, we'll meet the brain of the whole operation. Then, we'll give that brain a body. After that, we'll grab the digital tools needed, teach the device what it's supposed to do, get it to shake hands with your smart home network, and finally, we'll see the end result. Simple as that. All right, first up, let's meet the star of our show. The hero component for this whole journey is a little chip called the ESP32C6.
And here it is. I know, it doesn't look like much, right? But don't let the size fool you. This tiny square of silicon is what we call a complete system on a chip, or SoC. Basically, it's got everything it needs to be the central brain for almost any smart device you can think of, built from the ground up for the Internet of Things.
So what makes this little guy so special? Well, its real superpower is just how versatile it is. Sure, it's got a powerful processor, but the real magic is that it speaks pretty much every language of the smart home. You're talking the latest Wi-Fi 6, Bluetooth, Zigbee, and Thread. That universal connectivity, that's the secret sauce that makes it a go-to choice for so many new IoT products. Okay, so we have our brain, but a brain can't really do anything by itself, can it? So our next step is to build the physical hardware around it. We've got to give that brain a body so it can actually interact with the world.
And this is where we get into the hardware engineering phase. We're leaving the world of specs on a datasheet and getting into the real physical world of circuit boards, power supplies, antennas, you name it. The whole goal here is to create the perfect little ecosystem for that chip to do its job.
So what's in this life support system? Well, for starters, it needs clean, stable power. That's its food. Then it needs a heartbeat. That comes from a tiny 40 megahertz crystal that gives it a super precise rhythmic clock signal to keep everything running in perfect sync. And of course, it needs a voice, right? That's the RF circuit and the antenna, which let it talk to the world using things like Wi-Fi and Bluetooth. Oh, and it needs memory too, a little flash storage for its programming.
Let's actually zoom in on that voice for a second. Now, this diagram might look a little intimidating, but the goal is actually really simple. Engineers have to tune all these little electronic components with incredible precision. Why? To make sure the signal that goes out through the antenna is crystal clear, not a bunch of static. Getting this part right is absolutely critical. If you don't, the device just can't communicate reliably.
All right, our chip has a brain, and now it has a body. The next piece of the puzzle is the software. We need to get our digital toolbox ready so we can actually program that brain.
Think of it like setting up your workbench. The first major tool we need is something called the ESP-IDF. The easiest way to think about this is like the chip's basic operating system. It gives you raw, fundamental control over the hardware. Then, on top of that, we add another layer, the ESP Matter SDK. This is a more specialized toolkit that, you guessed it, teaches the chip how to speak Matter, which is that universal language for all smart home gear.
So how do developers get their hands on all this stuff? You might be surprised. It often comes down to a single, almost magical command. This one line of text right here, it tells the computer to go out and download the entire digital workshop for Matter. It just pulls everything in and sets up the whole environment so a developer can just start coding. It's that easy to get started. Okay, we've got the hardware, we've got the software tools. Now comes the really fun part, the creative part. It's time to give our device its personality. We have to teach this generic blank slate chip what its specific job is going to be.
Which leads to a really important question, right? How does a chip know it's supposed to be a light bulb and not, say, a smart thermostat? Because on its own, the chip is a total blank slate. Well, the answer to that puzzle is something called a data model.
The best way to think of the Matter data model is literally like a job description for the device. So at the top, you have the node. That's the physical device itself. Now, one device can have multiple functions, and those are called endpoints. Think of a smart power strip. It might have 3 separate outlets you can control, so that's 3 endpoints. Then, each endpoint has clusters, which are basically its skills. A light bulb needs an on-off skill, and maybe a dimming skill. And finally, you have attributes. These just describe the current status of those skills, like is it on or off, or is the dimming level at 80%? See, it's just a super organized way to describe what a device is and what it can do. So, at this point, our device knows who it is and what its job is. We're at the final step before it can officially be called smart. It has to join the smart home network. This is the big moment, the digital handshake.
The official term for this is commissioning, and the orientation day analogy is perfect. Imagine a new employee starting a job. You can't just let them wander around. They need to be securely introduced to the team, get their security badge, and given the Wi-Fi password. It's the exact same idea for our device.
And how does that whole introduction kick off? Usually with this simple little thing right here, a QR code. This code is generated just for this one device, and it's basically its secure invitation. It's the key that lets it into the smart home club.
What's amazing is how simple this is for you, the user, even though there's some complex stuff happening under the hood. So first, you scan the code with your phone or hub. That kicks off a secure handshake, usually over Bluetooth, where they swap all the secret credentials and your network info, like your Wi-Fi password. And then, boom, the device uses that info to connect. Just like that, it's officially on the team. And the payoff? Well, you can now control it. A developer might pop open a terminal and run a simple test command, just like this one, telling the device to toggle on or off. And when that works, that's the moment. That's the final proof that everything we've done has come together. The device is alive.
Okay, let's take a quick breath and just look back at the whole journey we've just walked through. It's pretty amazing when you see it all laid out, from a simple piece of silicon to a product you can actually control.
So, step 1 was the chip, our brain. Step 2 was the hardware, giving it a body. Step 3, we got our SDKs, the tools. Step 4, we used the data model to give it a personality. Step 5 was commissioning, that all-important handshake. And that brings us to step 6, the final result, a working smart product. And here's the most important takeaway from all of this. This whole process, which used to be incredibly complex and expensive, is now standardized and wide open for developers and creators everywhere. The tools are out there, the chips are more powerful than ever, and the protocols are becoming universal. It really just leaves you with one big, exciting question. What are they going to invent next?